Okay, so after almost a year of on and off, and a lot of videos, and a lot of time, and a lot of effort, and I know it took up a lot of time on this channel, and there hasn't been a whole lot of machining going on, but we're just about done with this machine. So as you can see, I got everything together, and everything moves like it should be, and it's pretty much a lathe again. So after this video, we're going to have one more assembly video, which is going to be of this, of the compound cross slide here. And then we'll get on to doing test cuts and leveling the machine. And then after that, we have three assemblies that we need to remake on this lathe. I'm going to replace the crossfeed screw and nut. I'm going to replace the tailstock screw and modify the nut. And I also need to make a carriage lock, because the carriage lock that was with this wasn't original and doesn't really fit in there. And the screw's missing, so I gotta make a carriage lock, and then this machine is done. Oh, the only other thing that I actually have to do assembly wise is I do have to paint the covers for the gear train and the bell housing. I just want to get those sandblasted, just because they're just pieces of metal. I've been putting it off, I'll be honest with you. I haven't wanted to take it to a place to get it sandblasted. So the subject of this video tonight will be twofold. Number one, I have to fix the compound Gibb that I broke when I disassembled it. Now, the screw that was there was bent. How it got bent, it could have got bent in multiple ways. More than likely, it got bent in a crash, judging by the fact that this was a school lathe and, you know, the chewy marks on the front of the compound. More than likely, it got bent in a crash. So the screw was bent, so the head wobbled. Now the head sits in the slot of the Gibb, so as I was unscrewing it, it got really tight and really loose, and I couldn't get it out, so I just had to bite the bullet and force it to get it out. The Gibb was loose, it would move back and forth, but the screw itself wouldn't move. So from that head actually moving back and forth, the screw was stronger than the cast iron tab that it was, and broke the little tab off the end of the Gibb. Not a huge thing, we can put it back together again. So you'll see that in this video. You'll also see me repairing the star wheel screw here. It's a left-hand thread, and rather than buying a left-hand die, which is relatively expensive, or trying to cut a thread pitch that small, left-hand, on a screw that small, I just repaired what was there. Now it was wallowed out, you'll see in the video. The slot was walled out, probably from somebody tightening it the wrong way, because it is left hand, so they're probably turning it the wrong way to try to either get it out or get it in. And also, I'm going to show you how to restore the tags. Now there are 4 tags on this unit. There's the one that's going to be going on the gearbox. There's the one the name tag is going to be going on the end of the bed. And there's 2 other tags, a actual model nameplate identification tag and a warning tag, which go on the gear cover. Warning tag goes right here, and the nameplate tag or lathe information tag goes right here. As you can see, these haven't been cleaned yet. So why don't we get to those, and we're going to get to the tags first. Okay, so here's a couple of the tags. This one is for the gearbox, this one is for the bed. This is a nameplate, basically, brand identification tag, and this is the information tag for the gears. Now they're brass and they are raised, so these letters here are raised. So what you can do is, there are people online that do make replacements, but they don't make a replacement, or I haven't seen a replacement for the 13-inch single tumbler gearbox. So you have a couple of choices here. Deal with what you have, clean it all off and leave it brass, or repaint it yourself. So I chose to repaint them. So you can see you can do two-tone or whatever you want. This was done with just masking tape. So masked off the red, spray painted the black, masked off the black, hand painted the red. This is from, the black is from a spray can, and the red is from a regular paint can with a brush. So now, in an ideal world, all these numbers and letters will be the same height, and you can put a nice piece of sandpaper, stick it to a surface plate, and rub it right off, and it'll take off just the top layer, leaving the bottom layer of paint. Well, this is not an ideal world because there are some little dents in here, so those are going to hit first and you're going to rub the paint off where you don't. So sometimes you have to go at these the hard way. The hard way is, and I'm pretty sure Keith Rucker showed this on one of his videos, take X-Acto knives and gently scrape the high points. So that's how we're going to do these. And then this one here is relatively nice and flat, so I'm still going to scrape all the high points, but then I'm going to put this on my surface plate and just give it a quick little buff, and that'll kind of blend in all the little scrape marks. You'll see how it turns out. It's not going to be perfect, but then again, we don't need it to be perfect. We need it just to look better than it did. And then we'll put a nice clear coat on this, and we can put it right back on the lathe. So it's kind of tedious work, so you got to be in the mood to do it. You guys get to fast forward through this. I get to sit here and scrape. So cue fast forward. Okay, there's the main name tag. Came out really good. This one I still have to let this, this is dry to the touch, but underneath it's still a little sticky. So I just gotta let that red dry all the way through, probably another 24 hours, and then just scrape it off. But you can see it's not perfect, but it's a hell of a lot more readable than it was. You see there. So like I said, I mean, if it's a pristine tag, you may have luck trying to do it with a surface plate, but this is too bent to be able to do that. So, like I said, we went about it the tedious way. And the other two tags, here's the name tag there, or the identification tag, and the warning tag. And these all get held on with little drive screws, which I have some right here. Which basically, it looks like a rivet. It has a very coarse spiral to it. You tap it in the hole, and that's how these suckers are attached. So I just gotta let this dry all the way through here a little bit more. I'll get this all scraped off, and then I'll put a nice coat of some varnish on there. That'll protect it, kind of keep that from tarnishing a little bit, and then we can attach them to the lathe. Alright, so this is the compound Gibb. Now, the screw on it was bent, so there is only enough clearance in this slot for the head. So when it wobbled back and forth, it actually ended up cracking it and breaking that little tang off. So now I'm just going to silver solder this back on. Now, I don't know if you guys can see in there. I got like, it looks like a little X. I just took a file and made that so that I have a little bit of a gap in it to make sure that I get enough silver solder in there. I should wick in by capillary reaction, but I just wanted to make sure I got a decent hold. And there's still enough of that crack to be able to register it. Now there's not really much pressure on this, so I'm not really worried about it. It's more or less the screw just holding it in place rather than taking any kind of pressure. Now my torch here, I have held it another vise at the angle that I need, because I'm going to need a hand to braze this, or take the silver solder and touch in there, but I also got to hold it down at the same time. So I don't have three hands, so I have another vise. So you know, we're using 45% silver solder and some stay still brazing flux. This is the white paste flux. So it's this stuff here. So if this gets chunky on you, you can add water to it, but this is a pretty new bottle. It's pretty fresh, so shouldn't have to. Now I cleaned this all up with a wire brush, and so we should be pretty good to go. So just a little bit of dab of flux, and whatever overflows on us, because there is going to be a little bit, at least a little bit of overflow on it, we'll be able to just file off relatively easily. And this is just a turbo tip, so this is air and oxygen, air and acetylene mix. That's all this is. Basic kind of plumbing HVAC torch. It's just what I have. I don't have an oxyacetylene rig. If you do have one, great, go ahead and use it, but this is what I got, so this is what we're using. Butterfingers today, hang on. Okay, take two. Okay, so I want to make sure I got that side. Okay, so we're just going to let that cool off, and then we'll dress it up. Alright, one other little quick brazing task that we gotta do is, this is the screw that goes in the middle of the star wheel. And it's a left-hand thread. It's actually 3/16 32. It's not 10/32. It's really close, but it's not. It's actually bigger. So you can probably get away with 10/32, but it's a left-hand thread, and a die is relatively expensive. So we're gonna repair this one. So you can see the slot is pretty much toast, probably from somebody that didn't know it was a left-hand thread. So what I'm going to do is just fill that up with braze, and then we'll remachine it flat and machine another slot in it. So got a couple pieces of aluminum here to kind of act as a pair of tweezers to hold this out over here, and hopefully they won't melt or sap too much heat away from that. I didn't want to hold it directly in the jaws. And we're just going to use a little MAP gas torch, should be more than enough to heat that up to red hot and fill that in. So let's get to that. Okay, we'll let that cool off. We can remachine it flat and then put a groove right in it. Okay, so there's a new screw with the slot, and then once I get this star wheel 100% painted, it's going to fit right in there like so. Okay, so thank you guys for watching, and thanks for sticking through this lengthy rebuild. I know some of you guys are here for projects, and those have kind of been like actual machining projects, and that's kind of been waning a little bit. But after the last assembly video, then we definitely have some good machining videos and machining content that's going to be coming your way. Like I said, I got to replace the screws. I also want to make a carriage stop for it, or a indicator holder on the carriage, but I want to do it differently than the one I have on the 9. I want to actually make it a cam action, so it have a lever and you can move it down. And also I need to probably going to make another collet chuck for this, another ER40 collet chuck for this, and we have to machine the back plate. So we definitely have some machining content coming up. So again, thanks for watching this video. Thanks for sticking through the series.